Good evening. It's really bold of you to have a visitor from out of county. So I will feel free to ask questions of you about San Mateo County, and I'd really be delighted to have any questions about what goes on in water supply in Santa Clara County. So in terms of groundwater, that's going to be the focus of my presentation. It really is going to be a question of what we've done over the last 85 years in our district in managing groundwater. Now, when I say that, Supervisor Pine mentioned a couple of cases where groundwater is becoming more important and being investigated further in San Mateo County, further up north with Bay Area Water Supply and Conservation Agency, SFPUC, and others are looking at some various conjunctive use on groundwater. Other agencies or county is doing some surveys to do with how you could investigate use of groundwater more. And further south in East Palo Alto, Ms. Fabry mentioned that East Palo Alto has recently, I think it has completed now a groundwater management plan. Certainly they've been involved with one. I know our district contributed in terms of data and supported that effort in terms of ideas and concepts as well. So even though it's out of our county, because there is no hard wall, physical wall between the two counties, and groundwater seems to migrate across despite the rules. We've been happy to work with them. And so in that context, I'd like to then move on and talk a little bit, why is it that groundwater became so important in Santa Clara County? It did, mainly because in the beginning when agriculture first settled in the early part of the 20th century, that's in the early 1900s, it was the only source that was really readily available for folks. I guess there was a little diversion of stream water, but mostly it was groundwater. And what happened over time is that groundwater, as it was utilized and the aquifers are nice and deep, the actual land started to subside a little bit. And that became a problem later on, as I'll explain a little bit more, in terms of how do you operate and build a city in a modern environment where you have a subsidence problem. In any event, groundwater was always important there. So what happened in terms of development is the water district, in order to address water supply issues and initial subsidence problems, its predecessor was formed, and the first thing that the district did was begin to find ways to supplement the water supply by building local reservoirs. And so over the next a decade or two or three, we built a number of dams around the surrounding areas, and I'll talk a little bit about the other areas too. In the hills surrounding the valley, many of you may have seen them, Anderson, Coyote, Lexington, those of you know some of them, there's others as well. So those were really built not for direct water supply use, piped to homes or piped to buildings, but simply as constructs in order to recharge creeks and ponds to get water into the ground. And I'll show you an interesting graph a little later about how well that worked. It was actually surprising to me. Back as a student, when I was in the 70s, I was a student at Stanford, and I kind of got interested in the groundwater situation in Santa Clara County. And I was quite astounded to realize that the concepts that we were looking at in the 1970s had really been thought of and were being developed back in the early teens and early 20s of the century. In any event, the issue here really had to do with how do you preserve that groundwater and move on? And I'll talk a little about that, backing up a little bit. So the ambitions of the district and its missions really have to do with clean and reliable water supply. Also, flood protection. There's been a discussion today about flood protection here in San Mateo County. And then also healthy creeks and ecosystems. We have interests and activities and work going in all of those areas. So then, as you go forward as to looking at meeting Santa Clara's water needs, we're serving about 2 million residents. We're a wholesaler of water supply, but we supply to 2 or 3 water supply companies, water distribution companies. For example, San Jose Water Company is the largest, but also a number of cities. And so our interests then get to be making sure that they don't have any concerns about the quantity and quality of our water supply. That's our focus in the water supply area. When you get into looking at the county as a whole and the systems that it has, somebody, I think, early on indicated, what is measured is managed. I love that slogan. So I'm going to give you a few measures about our county really quickly. 10 dams, 3 pump stations, 142 miles of pipeline, 3 water treatment plants, and the new water purification center on Zanka Road, which we call the Silicon Valley Advanced Purification Center, 400 acres of recharge ponds, 20 billion gallons of water supplied per year. And so those are a few quick facts, and so you can see how we manage relative to those. Also in terms of restoration, we have over 600 acres of restored habitats. We manage through flood control and various other measures, stream bank enhancement and so on, 800 miles of streams, and we preserve through flood control measures, levees and so on, and measures 100 parcels of land, private parcels. So then, in terms of a bigger picture too, even though I started the story talking about groundwater, you're going to ask me, why am I showing something that is not groundwater? This is imported water canal coming into the county. Well, I'll also illustrate that in a moment or two as to how important it is. It turns out that 55% of the county's water supply comes in through the delta or from the Sierras via pipelines and canals. And of that piece, 15%, in other words, 15 out of the 55 is actually supplied to the Hetch-Hetchy system by the SFPUC to various customers, some of whom are in the South, in the South Bay, in the Santa Clara County. And then we also are using more and more water in the county in recycled water. And it was around 5%, but this drought has kicked us up to over 6%, and it's been very important for us in this drought, and you'll hear more about recycled water in a moment. So the interesting thing about that, so in order to look at county sustainability, what we have going on here is these local reservoirs I mentioned that were constructed way back then in the early part of the 20th century. They're still there. We still operate them. They're very important. They provide groundwater recharge. That's really the most important things. Also, in addition to that, we do general groundwater management by wells, tracking, watching water levels, measuring water quality, making sure that conditions are correct and appropriate for water supply. We have an ambitious and very successful water conservation program, rebates, ideas, for people to implement in terms of how to save water at home. You've probably been inundated with your local cities and so on with all their ideas and requests and so on in this drought, and a lot of that has been very successful. So we've had long-term programs in that area, and in addition, during this drought, we have put out a huge amount of money, over $18 million so far in terms of turf rebates. So we offer $2 per square foot for turf conversion. Now that money has been utilized up very recently, but there are still programs being funded with that are still tailing off and being applied right now as we speak. That is enormous amount. Just in the first 9 months of this year, 2.8 million square feet, I don't mention acre, 2 million square feet of lawns and have been converted into more sustainable plants in the county. So then, in addition to those internal, what I would say is local management resources, we do have the imported water I mentioned, but we're also doing other things as well. We are adding the next phase of recycled water, which we call purified water. I don't know how many of you may have visited the Advanced Purification Center down on Zanka Road. There's been an open house very recently. We have tours. Sign-ups are pretty easy. We love visitors to show it around. That produces 8 million gallons of water a day, up to 8 million gallons of purified water a day. Purified water means if you take traditional recycled water and then take it through a reverse osmosis and potentially advanced oxidation process, you get it into a situation which is almost as close as distilled water and is safe to drink. We don't use it for drinking immediately. The plan is to put it into the ground. For the same general reasons as mentioned here in San Mateo County, we have an advantage by putting it into the ground, and that is there's storage available for when it's needed. In other words, if you produce more now, you don't need it now, but you produce it and pull it out during a drought. Also, the ground soils, aquifer materials provide additional filtration and enhancement of the purity of the water and more chemical balance to it. So there's many advantages to that. The other ideas for the future, which the district is interested in, has not developed as much as it was discussed by Mr. Fabry, with ideas of stormwater capture. Those ideas are still in fruition, although if you consider those 10 dams I mentioned, they were built in the early part of the 20th century, consider what they were. They are fundamentally stormwater capture devices, hold it back and then use it for recharge. They're the most effective things we have for stormwater capture, although now we're also interested, as Mr. Fabry's pointed out, in additional things that can be done downstream of those dams as the urban areas have developed. Is there something more that we could do? So then I promised this, and here we go. I will give you the little story. This is one of our favorite charts. Those of you who've been to presentations of the district will just have to bear with me, but it tells the little history. So I mentioned back in the earlier part of the 20th century, irrigation occurred, drew down the groundwater. This is the ground, this blue squiggly line is a trace of an indicator well. It is the real measurements of water depth in a certain well in the San Jose area over time. So you can see that water levels depleted. At this point around here is when most of the dams that were constructed by the districts became in operation and then started to hold back those storm waters and feed them into the streams and the ponds for a recharge. It pulled back the groundwater levels to quite a decent level, but development continued, and what happened then is levels fell and fell again, and quite substantially, and I'll show in a moment the consequences of that. What the district did at that point is it brought in water from the State Water Project, which is water that is really derived from Northern California, came in through the Delta, brought in that through pipelines, and managed to recharge that water in addition to the local recharge, brought water levels back up again. Additional water was brought in the 1980s from a federal project, the Central Valley Project, which enhanced it further. So over time, despite increasing demands, the district managed to keep the groundwater levels relatively good. This latest drought has drawn the levels down again. As you can see, we're watching that, and that's part of what's driven our water conservation. Our water conservation efforts is to keep the waters this too far. Now let me go to the consequence. This orange line here represents the land surface level, and over time in this particular area of San Jose, the land levels dropped approximately 13 feet. And that happens, those of you who are geomorphologists could probably explain this better than I, but as water is pumped from deep aquifers with clays, and those clay layers are depleted of their water, they compress, and even though water may be recharged to those aquifers, they don't rebound fully to their to their original space that they occupied, and so you have an overall compression of the soil layers deep down inside, which brings the surface levels down too. So that's the story behind us, and we manage the groundwater is the central focus of our county in terms of water supply. That's what we focus on most of all. So what does it mean in terms of such? This is a quick little example. Back in early 1900s, Alviso, the clubhouse at in the yachting marina, as you can see, is nice and high above the water level in the bay. This is I guess a harbor that existed even at that time. 100 years later, turn of the recent century, around 2000, you can see that's what happened is the water levels are way lower, way higher. They're behind a levee now. You have to climb up and down a set of steps to arrive at the same clubhouse over here, right over here. That appeared to be higher then, appeared to be lower then. It hasn't moved. Excuse me, it has moved. It's dropped about 13 feet relative to the sea levels. So that's something that the district takes very seriously when we manage our groundwater, when we bring in purified water to recharge the groundwater. We're really focused on what can we do, even while growth occurs and water demands increase, what can we do in order to keep the groundwater levels fully recharged so you don't get further subsidence. This drought has been pretty terrible. This is just a graphic image that you've all seen pictures of. Similarly, our board of directors called for 30% reductions. As of last month, the county had achieved approximately 27% reductions, which we think is pretty darn good. Folks have really stepped up across the county and really found ways to save water, particularly in the outside watering. So then let's talk a little bit more about the purified water. This is the plant down in Silicon Valley. So this came online in 2004. This tank here with the logo on it is simply a big balancing tank. This is the product water before it gets mixed with other water to be distributed throughout the county. So the whole concept behind this, actually let me step back, the whole concept behind the center was to produce this water, this purified water, initially as a demonstration plant, and that's in the phase that it is in now, demonstrate that at a fairly large production, that's 800 million gallons a day, we can do that day in and day out and achieve all of the water quality standards that's desired of it or required of us by the state regulators. And so that's what we've been doing. We have a test plan that is substantially complete now. Another phase will continue, in which case we're demonstrating that we can do it. We've had a number of tests that have been done over all this time. All of them have panned out just exactly as needed. So then we had an opening ceremony, and of course we had to have a little drama around it. So we had a little taste test, and on the right you have Mayor Sam Liccardo from the City of San Jose and Jamie Matthews from Santa Clara, and other dignitaries busy giving a little taste of the water, and they say it was pretty good. And it's all about public education, too. When we think about using these kinds of water, it's very important for us to be in touch with the public. And so with the test plan information, we provide that to everyone. Also, we've done various polls of individuals in the county. So the latest poll that was done in 2004 in Santa Clara County and in San Diego County, I think the results were similar, that once those who were polled had received a little information about the purity of that water that they could receive in this water, would they be amenable to that water being put into the ground and subsequently used for drinking water? So 62% at that time said no problems. And so, that, I think, compared to earlier perceptions, is a grand step forward. In Orange County right now, that's happening at a much larger scale than we're talking about right here. Large amounts of water going into the ground, being pumped from groundwater, and the public there has, with education and confidence in their utilities, has embraced that, and it's become a very important part of their water supply. And so that is the concept here too in Santa Clara County. We will build out probably another 32 MGD of these plants. It'll form, rather than the 5 or 6% of recycled water I mentioned earlier, it'll bring us over the 10% level in terms of total county supply. So all of this is verified by our on-site lab. It produces 175,000 tests per year on average. It's got the state-of-the-art equipment. It can produce almost any test that you can ever do for water, and we do them. And finally, just in terms of where do you go for more information, so the addresses at the bottom, the URLs at the bottom, are where you can contact us, or I'd be happy to stay around for a while and you chat to me. But I'd be happy to take any questions. Yes. So the question is, what is the source water that goes into the purified water? And it's a great question. I should have mentioned that. Zanka Road is situated right opposite the road from the City of San Jose's wastewater facility. So they produce recycled water, some of which is piped all the way south into San Jose. What we do with the purified water right now is we blend it into that recycled water and send it south. So that is the source. We use the wastewater from City of San Jose's wastewater facility. Yes? Cost per gallon. Right now, the plant costs $72 million to put in, and it's going to last, I think the numbers on that run around $1,500 to $1,500 an acre foot, and I could convert that into other numbers, but I think it's in that range. Any other questions? All right, well, thank you very much, and thanks.